All right, so these are geometric sequences, and so what makes a geometric sequence is that there is some ratio, some multiplier or factor that we are multiplying to each term to create the next term. So 2 times 3 is 6, times 3 is 18, times 3 is 54, and you can verify this by dividing each term by its previous term, and you'll see that they're all 3. That's our ratio, so we will now be using r, not d like in arithmetic. So r is ratio, a sub 1 is still a sub 1. So to create our terms, they're very, very similar. You think of a sub 1 as 2. So if we take a sub 1 and multiply it by 3, we get our 18. And then we take our 18 and multiply it by 3, we get our 54. So what's happening is the same thing as before. With a sub 2, we will use 1 ratio. With a sub 3, you notice we had to multiply r twice. So it'd be 2 r's. With a sub 4, we had to multiply the r 3 times, and a sub 4, we had to multiply it 4 times. So our term will form very, very similarly. We can also use fractions. So if it's dividing, not multiplying, you don't want to say divide, you want to say 1/5. And so if we did negative 1/5, we get negative 1, and then negative 1 times negative 1/5 is the same y, but you can still see a sub 2 is 1/1/5, a sub 3 would be 2/1/5, a sub 4 would be 3, and a sub 5 is 4. So we end up with this situation happening. A sub 3 is 2, a sub 4 is 3 r's, a sub 5 is 4 r's, a sub 6 is 5 r's. So a sub n would be n minus 1 r's. So it's very similar to our difference formula. So let's use this to find our 10th term. So we have our sequence here. So we want to find first what our ratio is. And if you take any term in its previous term and divide it, they should all have exactly the same ratio. And then a sub 1 is still our first term, which was 1. So if we want our 10th term, we would plug in 1, and then it's 10 minus 1, right? This is 1 for a sub 1. Let's go back. Our r here is 3, so we would end up with that. So this is 1, and then 3 to the power of 9. And so like we were talking about, if you have the 10th term, that would be 9 ratios. So we end up with 3 to the power of 9, which we can then plug in our calculator, which becomes 19,683. So that is our 10th term. So just to show you what these look like, this should look familiar to you, this formula. When you have r to the 5th, r to the 4th, r to the 3rd, these are exponentials. And so what we are dealing with is an exponential. So there's my ratio of 3, and my a equals 1. And if I graph it, connect the dots, there you go. You can see it is an exponential function that we are graphing here. So these are exponentials, which makes sense. There's your r and some ratio. So we will have very similar types of problems. So you can see these will be used with financials when we get to applications. All right, so let's try another one. In this sequence, we have 16, -8, 4, and -2. And you think, oh, it's an alternating, so you have to worry about that. No, they'll take care of themselves. So again, all you have to do is -8 divided by 16, and that would give us -1/2. So we have our ratio, and if we took 4 and divided it by -8, you see it's also -1/2, no matter what you do. Our a sub 1 is 16 here. So to find a sub 10, that would mean we start with 16. We have our ratio of a -1/2, so we're going to take 16, multiply it by -1/2 9 times. It's 10, take away 1, right? And then we plug that in our calculator. So that would be 16, and parentheses. Make sure you have the parentheses so that -1/2 will give us the correct sign. And so since our exponent is 9, we know it's going to come out negative. And it gives you this decimal, which is fine, but you notice it's giving us fractions here. So you want to hit math. Number 1, hit enter, and it'll give us our fraction, which is -1/32. And there you have it. These are geometric sequences, so they're exponential growth. So the way you can think about it is this one's being halved every single term. So you were at 16, and then 8, and then 4, and then 2, and then 1, and then 1/2, and then 1/4, and then 1/8, and then 1/16. And when you get a ratio of 3, this one's being tripled. So we're going to triple, 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 triple. They're growing exponentially. All right, thank you.